Better? I have a problem with the screen. Good evening, everybody. I'm Abdullah Awad. I'm from Palestine. I'm here to present my paper, Q backlog as a node metric for RBL. Here is my outline, and I will start with the introduction, feature review, system model, and then we will introduce our metric, and then we will conclude. First, as we all know, internet has become an inevitable part of our lives, and as we all know, the number of interconnected devices and of course, and the computing devices is exponentially increasing in the last 2 decades, and it's increased and is expected to reach about 50 billion devices by 2020. Moreover, recently we have many paradigms that has shown, like the IoT, which will enable the interconnectedness among the device, among the computing devices, anytime, anywhere in the world. For Internet of Things, we have many protocols and that have been issued. One of these protocols is the IETF routing protocol for low power and lousy networks, which is called the RBL, which has been issued to enable the IoT, to enable the Internet of Things over wireless sensor networks, and to enable the IPv6 packets to be carried over IEEE 802.15.4. As we know, each protocol has some parameters that affect its performance. For the RBL, one of the most important parameters is the routing metric. So we have to work in choosing the routing metric that will suit our applications or the needed requirements. For this, the back pressure routing works on route packets in directions that make the differential backlog between neighboring nodes as maximum as possible. And the queue backlogs, by it we mean is the length of the queue that is located in a node, and which we store in it the packets that we will be forwarded to other nodes. So the queue backlog is the length of this queue. For the problem statement for us, the problem is that the RBL in the network layer meets throughput challenges due to many reasons. Some of them, like the various coinciding applications that will be available in one physical network, the potential huge network size and the large number of devices that will be available, and the large amount of information and data created. For all of these, we have a throughput challenge that faces the RBL. So we need to find solutions that will increase the throughput of the network, that will increase the throughput of our network under the RBL. So, as I have said, we have back pressure routing protocol that is used for wireless sensor networks under lousy links, and this protocol has shown a very good throughput performance, and it proved to be optimal and in theory. So it is desirable for us to propose a new metric for RBL that will take the advantage of the RBL of dealing with low power and lousy networks, and at the same time to take the advantage of packet pressure to increase our throughput. So the objective is to have a metric, a node metric that is based on Q backlogs in order to increase our throughput for the RBL. That will take into consideration the advantage of the back pressure and at the same time to, of course, as I said, back pressure has some disadvantages that is related to the it has a high end-to-end delay, and a limited applicability. So we need to take the advantages of the back pressure and at the same time to keep the wide applicability of RBL. Low power and lousy networks. In low power and lousy networks, we mean any device. It is an embedded devices with restricted power and memory and resources, or of course are commonly upgraded by energy efficient. The low power and lousy networks and the Internet of Things are always interchangeable. Can be by when we say about Internet of Things, we may mean low power and lousy networks, and this meaning is interchangeable. Low power and lousy networks can be used for industrial monitoring, building automation, smart homes, and medicinal services. One illustration of the low power and lousy networks is the wireless sensor networks, and we can use the IPv6. When we use the IPv6 with the low power and lousy networks, then these sensors will be able to can be uniquely addressed and interconnected. IPv6 routing protocol, which I have introduced, the RBL. As I said, it is a de facto routing protocol for LLMs, for low power and lousy networks with IPv6. The routing protocol RBL uses an objective functions to compute the rank. The objective function is a collection or an arrangement of functions to compute this rank. Rank represents the relative separation of a node from from the root. So if this rank is increased, this means that this node is relatively has more cost to reach the root. So some of the node or the link characteristics can be used by RBL as metric or constraints. So we have many node and link characteristics that we have to use as RBL metrics, and this metric will be carried through the DAG metric container. Of course, now the related work to our topic. We have many authors and many research groups that try to enhance or to introduce new metrics for the RBL. One of them is authors proposed 3 multipath techniques developed in basis of RBL, of course, which are FLR, ELB, and ELB-FLR. It showed the results showed a better energy efficiency and network lifetime. Another study that tried to use also a multipath approach. It depends on load balancing of the network to increase, of course, also the lifetime and to overcome the problem of congested paths. Also, in 8 authors proposed RBL-based protocol for the mesh-based multi-gateway AMI. They also used an interference-based metric for rank computation. It showed a better throughput performance, delay, and delivery compared to RBL protocol. And I will go to the last one because it is the most important for us. And 3 authors tried to take the advantage of back pressure routing, and they proposed a protocol for for routing in low power and lousy networks. But it showed superior throughput performance of the back pressure. It has also, I said, better throughput, and but unfortunately it has increased the end-to-end delay. It has limited the applicability of the RBL, and it had a complicated design. Now, our queuing model, for us, we will depend on queues that is implemented in the link layer, as in each node will have each node maintains a queue to each of its neighbors, and each of these queues will hold up to maximum packet per neighbor. Of course, we have each node will have each node will generate an amount of data, and will have a forwarded data from other nodes also to forward to its neighbor nodes. This summation of the data generated and to be forwarded is SI. It's not clear here. Then we will use a matrix called a matrix of real values to model the path selection in RBL. Each value of M, let's say Mij, will represent the probability that this link Ij has the better metric, the best value of metric, and that it has the best metric. Only successfully received packets. And we have to say that only the received packets, the successfully received packets from children will be forwarded. So some of the packets will be dropped. So we can change, or we have to divide, or we have to model our system using a new matrix called Tij, which is equal to the values of the matrix M divided by the ETX, where ETX is the inverse of the reliability. ETX is the expected number of transmissions to transfer a packet from node A to node B. So because some of the packets will be dropped, so we have to factorize or to multiply our model by the inverse of reliability. Okay, so by solving a flow balance equation, we have if we want as I said, S is representing the summation of the data generated by the node and forwarded from other nodes. So the total number of data of the flow distribution will be represented by S equals ST plus lambda, where lambda is the total of data generated from the node, and S represented the data coming from other nodes, forwarded from other nodes, and this equation has the solution as we can see in 1, and using this equation in 1 we can find the Q length as found by Q equal S minus TR minus D, where S, as I said, it's the summation of the data generated and forwarded, TR is the transmitted data, and D is the dropped packets. And then, as we can see from 2, the Q value or the Q length can be calculated locally at the node, and we can find also the value of ETX. Yeah. Q backlog metric, W metric, our metric. The Q backlog, as I said, is the node packet Q length of the neighboring queue in a node to its neighbor node. We have to combine this metric with other metrics to find the weight of each link from a node to other nodes. So the W metric, Wij, is equal to a constant value times Qij, which is the Q backlog value that I speak okay, plus theta Ij, which is the corresponding cost of using a link, Ij. So, as I have said, we have to maintain a queue of outgoing packets at some layer of the node IB stack. So we decided to use the queues that have been already implemented in the link layer or the link layer queues to find the queue backlogs. Then to select the best parent, each node have to solve the following optimization problem as shown in 4. We have to minimize this value to find the best route, which is x multiplied by Qij plus theta Ij should be the minima for its neighboring node. Metric value will each metric value, of course, will be broadcasted in the DIA metric containers, and each node will, of course, will broadcast this value to its neighbors, and each neighbor node will update its value as well whenever there is a node. Whenever the Q link value or the use metric change, the W metric value will be recomputed as a moving average as following in equation 5, which is Wij equal B is a constant larger than 0 and less than 1, and Wij hat is the new value of the metric. So each time our new value is changed, we will recompute our metric according to equation number 5. Now,
just go to your conclusion, Madam.
But I want to say something. We can use our there is one commonly used metric in wireless sensor networks for lossy links is the ETX. So we can use this metric with our W metric using the equation in 7, but it's not here also. So we can only we have instead of theta Ij, we have to use the ETX value. So in this paper, we introduced the Q backlog as a node metric for RBL in order to face the problem of throughput that results from, as I have said, the large size network, the high number of applications, and also, as we have shown, we can use this metric with other metrics like the ETX or any other one. Thank you. This is the reference.
Okay, thank you very much, Brother Abdullah. The question and answer can be done during the team break. So I would like to call Professor Shihab Abdulhamid to present his paper entitled Towards Heterogeneous Computing, Addressing Index Equation ON